Hello students, how are you? I am Dr. S.K. Das from Regional Institute of Education, Bhubaneswar. Once again, I am standing before you for the live interaction about an interesting chapter, Motion of your class, which is in the NCERT textbook. Let us first see what we learnt in earlier classes. We have learnt rest and motion. Then we learnt rest and motion are relative. Then types of motion such as linear, circular, rotational and vibrational motion. Then we learnt distance and displacement of an object in linear motion. Then we learnt uniform and non-uniform motion of an object in linear motion. Then we learnt speed, velocity, acceleration in linear motion. Then we learnt distance time graph in linear motion and velocity time graph in linear motion. Well, let us see what we will learn today. So finally, today we will learn about the equation of motion in linear motion by graphical method. Please remember, we have to study the equation of motion in linear motion by graphical method. Then we will study the uniform circular motion. So these are the two concepts we will be learning today. Well, so before we go for the first learning point, that is equation of motion, first of all, I will ask this pertinent question. What is meant by equation of motion? Do you have any idea about equation of motion? Well, so you must have some idea about equation of motion, because equation means a equation which represent the motion of the object. So therefore, equation of motion is a set of three equations. It's not one equation. Equation of motion is a set of three equations relating to velocity, distance covered by an object in certain interval of time, and uniform oscillation. So in the equation of motion, you have the physical quantity like velocity, like distance covered, like time taken by the object, like acceleration of the object. So equation of motion is a set of three equations relating velocity, distance covered by an object in certain interval of time, and uniform oscillation. So this is called the equation of motion. So can you find out who is the person who explored this equation of motion? Newton explored this equation of motion. You have to find out the history of science. Then you see, so Newton is the person who explored this equation of motion. What are these three equations? I have already told there are three equations in the equation of motion. What are these three equations? So these are the three equations. First equation is V equal to U plus AT. Second equation is S is equal to UT plus 1 by 2 AT square. The third equation is 2AS equal to V square minus U square. The first equation is known as the equation of motion related to velocity time relation, and the second one is related to position time relation, and the third one is related to position velocity relation. So what is V? V is the final velocity of the object that we know well from our earlier class. What is U? Initial velocity of the object. What is A? Is the oscillation of the object. What is T? T is the time taken. So the parameters are, or the physical quantities are, U, initial velocity, V, final velocity, S, distance, T, time taken, A, acceleration of the object. So these are the three equations, and these three equations are known as the equation of motion. Well, Let us see how to derive the equation of motion by graphical method. In your syllabus, this is mentioned. You have to derive the equation of motion by graphical method. There are different methods, and you have understood about the distance time graph, velocity time graph. So, by graphical method, you have to derive the equation of motion. Then how to derive? If question is how to derive that equation, you see, first of all, by considering an object in linear motion with uniform oscillation A. You have to consider an object which is in linear motion with uniform oscillation. That means oscillation of the object must be constant. If the oscillation of the object is constant, then obviously the velocity time graph must be a straight line, okay, passing through the origin, but it is not parallel to the time axis. Remember, I have already explained this particular concept in my previous class. If u is the initial velocity of the object, v is the final velocity of the object in time t, then velocity time graph AB is, nature of the velocity time graph is shown in this figure. See the velocity time graph. I have already explained this particular graph. So here, see, u is the initial velocity. It is equal to OA because that is given in the y-axis. So OA is equal to u. V equal to final velocity equal to OE. So see the point E in the top of the graph along the y-axis. So that is the point E. So OE is equal to V is equal to final velocity. Then along x-axis you see OC. O is the origin, C is the point. So OC is equal to T equal to time interval. So the object moves with an initial velocity u, then it attains the final velocity v after time interval t. T is equal to OC. That is given in this velocity time graph. First of all, you have to understand this. Then you have to draw perpendiculars. First perpendicular you have to draw, that is the BC on the time axis. See the time axis. On the time axis, you have to drop a perpendicular BC. This is the bigger figure and this of course the smaller figure. So BC is the perpendicular on the time axis. Then again another perpendicular you have to draw. What is that? That is BE is the perpendicular on the velocity axis. It is not on the time axis. It is on the velocity axis, BE. So these perpendiculars you have to draw. BC on the time axis, BE on the velocity axis. Then one more perpendicular you draw. What is that? That is perpendicular AD on BC. Perpendicular AD on BC. See, BC is the perpendicular from point B on the time axis. Now you have to drop a perpendicular from the point A on BC. So that perpendicular is AD. That's why I have mentioned here, draw perpendicular AD on BC. What we will get? We get ABD right angle triangle. Am I right? See the bigger figure. ABD right angle triangle. And here BAD angle is equal to theta. That's what I have mentioned here. ABD right angle triangle we are getting, and we are getting two rectangles. What are those? OADC is the first rectangle and the second rectangle is OEBC. Okay, these two rectangles we are getting. And finally we are getting a trapezium, that is OABC. Let us see from the bigger figure. See, OADC is the first rectangle we are getting. Then OEBC rectangle we are getting. OABC, OEBC rectangle we are getting. Then we are getting a trapezium OABC. So here we are getting these figures, ABD right angle triangle, OADC and OEBC rectangles, and OABC trapezium. Then after getting this right angle triangle, rectangles and trapezium, then we can derive the equation of motion. So let us go for the first equation of motion. What is that? V equal to u plus at. So how to derive? We have to take the ABD right angle triangle. see ABD right angle triangle, where angle theta is equal to BAD angle. So therefore, I have mentioned tan theta is equal to perpendicular divided by base. BD is the perpendicular, base is the AD. So BD by AD is equal to tan theta is equal to BD is equal to BC minus DC. Here you see you have drawn perpendicular, that is AD on BC. So therefore, this BD is equal to BC minus DC divided by AD. So this tan theta is equal to perpendicular divided by base. So that is perpendicular is the velocity, base is the time. So velocity by time must be equal to acceleration. So therefore, tan theta is equal to acceleration is equal to A. So here the object in uniform oscillation motion, because the slope is constant. Therefore, the acceleration A is equal to constant. Then in OABC rectangle, see OABC rectangle, OA is equal to DC is equal to initial velocity U. In OEBC rectangle, OE is equal to BC is equal to V. In OADC rectangle, OC is equal to AD is equal to T. So from these rectangles, the value of OA, value of OE, value of OC are given. Then you have to substitute the value of BC, DC and AD in the expression for the acceleration. Tan theta is equal to BC minus DC by AD is equal to acceleration A. So therefore, A is equal to, substitute the value of BC, BC minus DC by AD. So BC minus DC is equal to OA, therefore BC minus OA divided by OC, because OC is equal to AD, is equal to V minus U by T, because you are substituting the value of BC, OA and OC here. BC is equal to V, OA is equal to U and OC is equal to T. So if you, go for, manipulating the equation, so V minus U equal to AT, or V equal to U plus AT. V is the final velocity of the object, U is the initial velocity of the object, A is the uniform oscillation and T is the time. So this is called the velocity time relation. So in this way, you can derive the first equation of motion. Then you must be interested to derive the second equation of motion. So what is the second equation of motion? S is equal to ut plus half at square. This is the second equation of motion. Then how do you derive this equation? Again, by using the same velocity time graph. Take the same velocity time graph. Of course, I have shown you the same velocity time graph. The object moves with uniform oscillation. Now distance covered by the object under velocity time graph is equal to area of the trapezium OABC. OABC is the trapezium. I have already explained you how to calculate the distance from the area under velocity time graph. So that you are going to find distance of the object under velocity time graph is S equal to area of the trapezium OABC. So here you see inside the trapezium you have a triangle ABT, ABD and you have a rectangle OADC. Therefore, area of the trapezium OABC is equal to area of the triangle ABD plus area of the rectangle OADC. You know what is the area of the triangle, half base into height. You know area of the rectangle, length into breadth. That you have to put here. So S is the distance is equal to half base is equal to AD into height dB plus length OC into breadth OA equal to 1 by 2 into AD into dB. dB is mentioned CB minus CD from the figure. So dB is equal to CB minus CD. So therefore it is 1 by 2 into AD into bracket start CB minus CD bracket close plus OC into OA. Now substituting the value of AD is equal to OC is equal to T, CB is equal to V, final velocity in this figure. I have already told you. CD is equal to OA is equal to U, that is the initial velocity of the object. Then we get S is equal to 1 by 2, AD is the T, CB minus CD, that is V minus U, plus OC into OA. OC is T and OA is U. T into U equal to UT plus 1 by 2 T into V minus U. Then from first equation of motion, you know V equal to U plus AT, or V minus U by T is equal to A. Then you can substitute the value of V minus U is equal to AT. Here you see V minus U is there in the bracket. Now if you substitute V minus U is equal to AT, then we get UT is equal to, S is equal to UT plus 1 by 2 AT square. So this is called position-time relation. This is the second equation of motion. Then you must be tempted to derive the third equation of motion. Am I right, students? Well, now you tell me what is the third equation of motion. It is V square minus U square is equal to 2AS. And you know the parameters. So here again you have to use the same graph, velocity time graph under uniform accelerated motion of the object. Whenever you use the same graph, then you have to find out the distance covered by the object under velocity time graph. You know the technique, how to calculate the distance covered by the object. So distance covered by the object under VT graph is S equal to area of the trapezium OABC. Here you know from your mathematical knowledge about the area of the trapezium, that is half into sum of the two parallel sides into perpendicular distance between the parallel sides. So here in this figure, the trapezium is OABC, parallel sides are OA and CB. So half into sum of the two parallel sides is equal to 1 by 2 OA plus CB. Then perpendicular distance between the parallel sides is OC. So therefore the distance S is equal to area of the trapezium is equal to 1 by 2 OA plus CB into OC. Now substitute the value. What is OA? Initial velocity U. What is CB? Final velocity V. And what is OC? That is the T. If you substitute these values in the above equation, then the distance covered by the object under VT graph is S is equal to 1 by 2 in bracket U plus V into T, because OC is the T, equal to 1 by 2 whole into V plus U into T. Then from first equation of motion we know V equal to U plus AT, AT is equal to V minus U, T is equal to V minus U by A. Now distance covered by the object S is equal to, now substitute the values, because here you have to substitute the value of the T. If you substitute the value of T, so what is T? V minus U by A. Then S is equal to 1 by 2 V minus U into V minus U by A equal to V square minus U square by 2A. Then 2AS equal to V square minus U square. So this is the third equation of motion. This is called the position velocity relation. So these are the three equations which represent the equations of motion. Now you know how to derive equation of motion by graphical method. The graph you are using in this case, velocity time graph, under which an object moves with uniform accelerated motion. So here, what are the limitations of this equation of motion? That is very important. Students, you should understand where this particular equations is valid. This equation of motion valid for linear motion of an object with uniform oscillation. That means oscillation must be constant. A is equal to constant. Then equation of motion with U is equal to 0. What is U? Initial velocity. When initial velocity is 0 and A is equal to G, in the next class you will be studying, or in the next chapter you will be studying acceleration due to gravity. So here G is equal to A. If you substitute U is equal to 0 and G is equal to A in the equation of motion, then the equation of motion for the freely falling body, V equal to 0 plus AT is equal to 0 plus GT is equal to GT. S is equal to 0 plus 1 by 2 AT square is equal to 0 plus 1 by 2 GT square is equal to 1 by 2 gt square. Then 2as is equal to 2gs is equal to v square minus 0 is equal to v square. So these are the equation of motion for a freely falling body under the action of gravity. Well, students, so we understood about the equation of motion and how to derive the equation of motion by graphical method. Let us learn about the circular motion of the object. Of course, whenever we have studied the type of motion, and we have studied basically there are 4 types of motion. One is linear motion and the second one was the circular motion. And you please recall the previous knowledge from the previous class about the circular motion. And we have seen if an object moves in circular path, then the motion of the object is known as circular motion. And we have seen through activity of the toy train moving in circular track. And we have seen the ball, of course it's a paper ball, whenever it is tied with a cotton string and revolve in a circular path. So then the motion is said to be circular motion if object moves in a circular path. Then let us see this activity. Again it is the activity related to the toy train. The toy train moves with uniform speed. Here the speed of the toy train is constant. But does the direction of speed constant? No, not at all. Direction of speed changes continuously. Then see the next activity. Paper ball tied with a cotton string moves in a circular path with constant speed. If the string is caught by a scissor, you take a scissor and cut the string instantly whenever it was revolving, then the ball, whenever the ball is in circular motion, the ball just flies away tangentially from the circular path. Well, what do you observe in these activities? Both the toy train and paper ball moves in circular motion with uniform speed. But the velocity, you see, at the top it is v1, then v2, then v3, then v4. Velocity v1, v2, v3 and v4 of course changes continuously at regular interval of time. See the direction of velocity tangential to the circular path. Just now I have explained, whenever cut the string by a scissor, then the ball flies tangentially to the circular path. That's why the direction of the velocity is tangential to the circular path. So direction of velocity continuously changes at regular interval of time. Although the magnitude remains constant, but direction of velocity changes continuously at a regular interval time. So the paper ball and the toy train moves with uniform oscillated motion. Oscillation is equal to constant here. Well, so let us define uniform circular motion. We know about circular motion and we know here the oscillation of the object is uniform or constant. But the path of the object is circular. So that's why let us see the definition of uniform circular motion. So what is uniform circular motion? If an object moves in uniform speed in a circular path, the motion of the object is known as uniform circular motion. So I think you have enjoyed this uniform circular motion. You have enjoyed the uniform linear motion. Now you try to enjoy the uniform circular motion of the object. Then how do we find uniform speed in uniform circular motion? So we know from the definition of speed, speed is equal to distance traveled by time taken. For one complete round of revolution of the object in circular path of radius r in time t, the uniform speed of the object is equal to 2 pi r by t, because the distance traveled is equal to 2 pi r for one complete round of revolution in time t. So distance traveled is equal to 2 pi r, time taken is equal to t. That's why the speed is equal to 2 pi r by t. That remain constant because r is constant, t is constant. That's why 2 pi r by t is equal to constant. The speed of the object is constant. That's why here the motion is uniform. So in this way you can calculate the uniform speed of the object by calculating the radius of the circular track and time taken by the circular track for completing one revolution. Let us understand the equation of motion and circular motion with the help of some interactive questions. See the first question. Find the acceleration of your bicycle starting from your home to attain the velocity of 20 meter per second in 2 seconds, assuming uniform accelerated motion of the bicycle. I have already told you everybody should ride a bicycle. Cycling is the best exercise. That's why this is a pertinent question related to bicycle riding. You start from your home and attain the velocity of 20 meter per second in time 2 seconds. Then you assume the acceleration is constant and you have to find out that acceleration. Use the first equation of motion, v equal to u plus at, a equal to v minus u by t. Now substitute the values of u, v and t. U is equal to 0, v equal, because you have started from the home, that's initial velocity is equal to 0. Attain the speed or the velocity is equal to 20 meter per second and after time t is equal to 2 seconds. If you substitute the values, then a equal to 10 meter per second square. Then second question, find out the distance traveled by your bicycle by attaining the speed of 20 meter per second in 2 second time in the above question. Please remember the above question and see the result. Remember the result. Acceleration is how much? In the previous question, 10 meter per second square. So here same acceleration is there, but you have to find out the distance traveled. So how to find the distance? Then use the second equation of motion. S is equal to ut plus half at square. In this situation, or in this case, initial velocity u is equal to 0. Acceleration already I have told you, 10 meter per second square, you have calculated in the previous question. Then at time t is equal to 2 seconds. Then s is equal to, substituting the values, 0 plus 1 by 2 into 10 meter per second square into 2s, 2 second square, equal to 40 by 2 meter is equal to 20 meter. So distance travel by the bicycle must be 20 meter. Then this is the third question. If you apply brake in your moving bicycle, which produces acceleration of 10 meter per second per square, 10 meter per second square per second per 10 meter per second square in opposite direction of the motion of the bicycle, and just after 1 second bicycle stops. Find the distance traveled by the bicycle during that time. Students, remember, whenever you ride the bicycle, you must take care that your brakes must be proper, because that will prevent you from the accident. Well, so how to start with this question? The parameter given in this question, in this case, the final velocity after giving the brake, the final velocity of the bicycle must be 0 because you stop there. Acceleration is equal to negative because velocity decreases. Finally, your bicycle stops. That's why acceleration is negative, a equal to minus 10 meter per second square. Then from first equation of motion, v equal to u plus at, u is equal to v minus at, substituting the values of v equal to 0, a equal to minus 10 meter per second square, t equal to 1 second, then you find u is equal to 10 meter per second. You calculate and check whether it is correct or not, 10 meter per second. Then from third equation of motion, you know 2as is equal to v square minus u square. Then you substitute the value of v is equal to 0, u is equal to 10 meter per second, a is equal to minus 10 meter per second square. In the expression for s is equal to v square minus u square by 2a is equal to 0 minus 10 meter per second whole square divided by 2 whole into minus 10 meter per second square is equal to 5 meter. Please check the calculation. Then see the fourth question, an artificial satellite. Whenever artificial satellite is there, see the artificial satellite is moving in a circular orbit of radius 42,250 km. Calculates its linear velocity if it takes 24 hours to revolve around the Earth. You know about artificial satellite, lot of research is there by means of artificial satellite revolving around the Earth. Radius of that circular orbit is 42,250 km. Then you have to find out the linear velocity of the satellite if it takes 24 hours to revolve around the Earth. Then you know the equation, to find out the linear velocity. Of course, the magnitude of linear velocity is the speed. I have already explained in my discussion. Speed is equal to uniform speed is equal to 2 pi r by t. Now substitute the value of pi, that is 3.14. Substitute the value of r, 42,250 km. Substitute the value of time, 24 hours, is equal to 24 into 60 into 60 seconds. Then if you solve this question, then the speed of the satellite or the magnitude of the linear velocity v equal to 3.1 km per second. But check the result. Now question number 5. A ball is gently dropped by Sita from a height of 20 meter above the ground, and the ball moves downward with an oscillation of 10 meter per second square. With what velocity will the ball strike the ground? This is the first part of the question. Second part of the question is, after what time will the ball strike the ground? What would be the solution? In this case, acceleration is a equal to 10 meter per second square. It is already given. U is equal to 0 because the ball started moving from rest. That's why U is equal to initial velocity is equal to 0. Then distance traveled 20 meter height. 20 meter is the distance. S is equal to 20 meter. Then from third equation of motion, 2s is equal to v square minus u square. V square is equal to u square plus 2s. Now substituting the value of u equal to 0, a equal to 10 meter per second square, s equal to 20 meter. Then we get v square is equal to 20 meter per second whole square. Then obviously velocity is equal to 20 meter per second. The ball strike the ground with velocity 20 meter per second. Then time taken. What will be the time taken by the ball to reach the ground? From the first equation of motion, we know v equal to u plus at. So t equal to v minus u by a. Now substituting the value of the final velocity, v equal to 20 meter per second, just now we have calculated. U is equal to 0 because the ball started from rest. Initial velocity is equal to 0. Acceleration a, already it is given 10 meter per second square. If you substitute the values of v, u and a in this equation, then t equal to 2 seconds. So please check the calculation. The ball will take 2 second time to reach the ground. Well, students, let us see this activity. I am just giving this activity to you. Derive the equation of motion by using graphical method from velocity time graph with the zero initial velocity of the object in uniform linear motion. Remember, you have to derive the equation with a particular condition. What is that condition? That the object started with an initial velocity 0 with uniform linear motion. From velocity time graph, you have to derive the equation. Then what we have learned today? We have learnt about the equation of motion. We know a set of 3 equations relating velocity, distance traveled by an object in certain time interval, and oscillation known as the equation of motion. Then there are 3 equations: v equal to u plus at, velocity time relation; s is equal to ut plus 1 by 2 at square, position time relation. Then 2s is equal to v square minus u square, this is the position velocity relation. Then we have derived the equations. First equation, second equation, third equation by using velocity time graph under uniform oscillated motion. So by means of this graph, we derive the equations. Then we have studied uniform circular motion. We know if an object moves with uniform speed, v equal to 2 pi r by t, where r is the radius of the circular path, t is the time taken to cover one revolution around the circular path, then the motion of the object is known as uniform circular motion. So this is the exercise for you all. Please do these multiple choice questions by selecting the right choices. See first question, read the question carefully and select the right answer. Read second questions, third question, fourth question, fifth question and sixth question. Read these questions carefully, then choose the right answer, choose the right choice. Then read question number 7, 8, 9, 10, 11 and 12. Different figures are there, and check the right answer, right figure whenever you solve these particular questions, multiple choice questions. Of course, answers I have given at the last. First of all, you independently solve the questions, then independently take the right choice, then go for its checking with the help of this key, that is the answer key. Then you will be confident and your idea will be clear. So today we have completed the chapter. So before I conclude, I am giving a suggestion to you. Read the chapter Motion of NCERT textbook thoroughly and understand the concepts. Then solve all the questions given in the textbook and solve the numericals given in the other books. Do all the activities given in the textbook and develop at least 5 similar activities by yourself. Unless until you develop the activities, develop some of the kind of conceptual working models, then your knowledge will be incomplete. Well, thank you for your patience hearing. Thank you for your interest. And I hope all the best. And during this pandemic situation, you must be, enjoying this online teaching with the help of lot of questions, interactive questions in particular, lot of activities, lot of conceptual discussions, and lot of interactions, not only with me, but also with your friends. You must have enjoyed, students, no? Well, thank you. Thank you so much.